when we say Ohm's law, applied gani siya sa kanang electrical circuit. So for Ohm's law, it states that the voltage in a circuit, since we're talking about electricity, so the voltage V, ato ikon voltage V is directly proportional to our current. So ngano nakaingon man siya niani. By this law, iyaning gi-relate sa kanang kuan, sa kanang principle sa fluids, di ba? If we have, as you can remember in our discussion in fluids, di ba, if we have a water tank, let's say natay water tank at a higher elevation, and then napuda diri at a lower elevation. Okay, let's say man siya ang ground. So ang analogy sa kuryente gi-relate sa analogy po sa fluid. So ang volume would be the pressure. So volume would be the pressure over water here. So as you notice, kung kani siya, so kani siya diri nag-exert ni siya higher pressures. So mo flow siya ngadto, mo flow. Okay, mo flow siya ngadto. Or we can just reiterate the figure para mas masabtan ninyo. Let's say area. Let's say a simple water tank lang yun. Let's say if we have here a tank of water, then nadre ay water level, and then diba sa fluids at a certain depth, or as the depth increases, so mo increase po ang atong pressure. Let's say mo na siya ay depth diri. So if magkaanam og kalawom, di ba, ang pressure adi kay kusog kayo. Okay, so mao po na siya, ang pressure represents our voltage. Okay, the water pressure represents our voltage, and the current represents the volume flow rate. Okay, ang amount of flow diri mo na siya nag-represent sa ato ang Q, the volume flow rate of water. Of course, kung diri ta magbuho og kanang kuan, we're going to create a hole here. Of course, ang flow diri, ang current, let's say this is Q2, it is lesser than Q sa ubos, tungod kay ang height diri migamay, so ang pressure pod migamay. So the same thing with our kuan class. The same thing with our kanang electrical circuit. Let's say if we have a simple circuit, let's say battery, then natay, let's say this one is a light bulb. Okay, so if kaniadto ang kuan battery, mo siya nag-serve as our water tank. Now if taas kay siya pressure, or shall we say taas iya voltage, then ang iyahang kuan, of course, ang battery nag-contain mo siya electronic charge. So na siya mga charge kanang particle. Okay, na siya mga charge particle. So kung dako kaya pressure, so meaning maka-flow siya aning mga charges kaning electrons, di ba? Electrons, so mo flow ang electrons. Kung taas kag voltahe, so mo flow ang electrons, and then ang speed, di ba, or ang kanang volume flow rate, ang speed sa pag-travel sa atong electrons, atong mga charges, kay i-quantify na siya by our current I. So ang current is charge per unit time. The same thing with our volume flow rate, that is the amount of water per unit time. So analogous ra kaayo ang ato ang kanang Ohm's law sa fluid pod. Okay, so mo na siya, voltage is directly proportional to our current, but of course, in order to make this one into an equation or a formula, we must have a proportionality constant. So that would be voltage equals some proportionality constant. We denote this one as R, and then I, or voltage equals I R. So ang proportionality constant is what is known as unsa man. Are you familiar with R? Unsa man R ani class? In idea on something R? Unsa man siya? Are you still following? Unsa man ang R? Okay, resistance. Sakto. So resistance na siya. So meaning di ay di ta makaingon nga if we have a voltage here, tao katag voltage and then kanang kuan, of course maka-flow ta og daghang current at a certain period of time because that is charge per unit of time, but we cannot sure nga kanang kuan, or we're not sure nga kuan ta maka-flow dayon ta from battery to our bulb without any resistance or restrictions. Of course, in reality kani atong wires, of course kani siya, kani this is our connecting wire and this is our bulb. In reality di man gini siya 100% nga kuan niya ma-flow agad-agad dayon ang charge from the battery to the bulb. Of course nam ginay resistance sa tong wire, meaning iyang gipugngan ang flow. The same thing with our pipe, di ba? Sa atong water pipe, di ba nam na yung mga deposits ara, and we term this one as falling. So na mga deposit, mga sediment, of course if nanay mag-clog ara, so mas mahinay ang flow, di ba? Mahinay ang flow. The same thing with our electrical circuit. If our connecting wire offers greater resistance, so meaning it's either or, normally mo hinay ato ang current. So that's why the relationship between current and resistance is inversely proportional, because if we're going to reiterate Ohm's law, or we're going to kanang derive Ohm's law, kato siya i-derive, so in terms of resistance mahimo na ni siyang kuan, mahimo siyang R is equals to V over I. And also if that is in terms of kanang current, that would be I is equals to V over R. So meaning if our resistance increases, our current decreases, and the same thing with here, if our current increases, our resistance decreases. Okay, and then dimensional dimensional analysis. So our current I, ang iha dimension is unsa man class, na may idea unsa ay dimension sa ato ang current? Wala mo ani sa inyo ang senior high electricity? Unsa units? Wala wa kay ba unit? Wala. Ang unit sa current is ampere, or ang iyahang actually ang ampere na derive ni siya sa coulomb per second, or ampere. Ato rin gidinote as capital letter A. And then ang unit pud sa kanang sa may unit sa voltage, na idea unsa man? Wala gyapon. Ang unit sa voltage is in volts, then gi-abbreviate siya as capital letter V. And then for resistance, ang unit niya is ohms, and then gi-abbreviate siya as siya omega. Okay, so maran ninyo hang kanang tigaman. So again, voltage equals IR. So ato na siya ma-model using sa ato ang kanang fluid mechanics nga principle kaning sa pressure sa tubig. So again, ang atong voltage is analogous na siya sa pressure sa atong tubig, kay if we have a greater amount of pressure, so the same thing with our battery, if our power source has a greater voltage, then it has the capacity to exert greater current, that is the amount of charge that is passing through a wire or through a connecting or through a conductor per unit time. And then of course in reality dili man gyud nga di man gyud ta maka-offer og 100% nga flow sa ato ang mga conductors, namgi resistance. So mao nang natay gi-incorporate nga parameter R sa atong equation. That's why we have voltage equals IR. So mo na siyang Ohms law, and from Ohms law, okay, from Ohms law we can also derive, so let me join, from Ohms law we can also derive the power. So power, let's say if you're having a simple circuit na siya, so simple circuit ana, of course sa ato ang circuit nagid tay source of power, source, and then of course that is here, let's note this one as positive and negative terminal, diba? So battery nabgin na kuan positive and negative terminal, and then assuming nga wala ni siya switch, so connected directly, and then this one, this is our bulb. Okay, this one is our bulb. Of course kani siya, this one connects our source and our bulb, so this is our conductor or connecting wire. So di ba, as what I have told you earlier, kanay atong power source or ang atong battery, mura na siyang tangke sa tubig. It possesses a certain amount of voltage. So na siya voltage, and we're going to abbreviate this one as V, or other books gi-abbreviate siya as E. Kay ang other term for voltage class is what we known as EMF, or gi-abbreviate na siya as electromotive force. Okay, kung inaon mo find the EMF, the same na po na siya sa voltage. So mo na siya gitawag pud na siya og electromotive force. And other term for voltage is sa paman. Are you familiar with potential difference? Potential difference. So nga nang gitaw mo siya potential difference, mura na siya same sa water ba nga ang difference sa pressure from a certain level to another level, mo nang term po siya nga potential difference, ang diferensya sa kanang voltage from one point to the other. So mo na siya ang tawag sa other term for voltage, EMF or potential difference. So here mo na tong battery atong source, so for every source nagana siya gipossess nga EMF or potential difference. Next one, sa atong conductor, of course, the current flow from the voltage from the positive towards the negative. That is the sign convention. However, in reality, good class, ang travel gid sa charge is from the negative terminal to the towards the positive. Diba? Kaya ang electron, kaya ang sign sa electron kay negative man, ang protons kay positive. So therefore, scientifically, ang flow gid niya is pabalik tayo yun, but para na ay standard ang tanan from positive to negative na lang. Actually mo na yung actual nga flow gikan negative to positive tungod kay diba, so I have told you the sign for electron is negative kay they are negative charge particles and protons are positive charge particles. So meaning inside our battery, sa sulod sa atong battery dire on the negative terminal daghan ra mga electrons, so negative particles, and then sa positive terminal nadra ang mga kuan protons nagpundok. And then di ba si proton baya kadi biya namo ang mo travel, si electron baya ang mo travel. So meaning sa to ang battery kata ni padako na tong kuan battery ngana di ba sa law of attraction ha. So if we have a lot of negative here, meaning we have lots of electrons on the negative current terminal, and then of course here sa babaw naatay po yung mga positive ang mga particles. These are protons. So if ever daghan tag concentration sa kan electrons are sa negative terminal, of course we exert a lot of man kanang potential difference or electromotive force, voltage. So mapod na sa tubig sa tangke. Kung daghan kag tubig, dako kag pressure. Diri pod daghan kag concentration sa electrons pa sa negative terminal, dako pod imong voltage. So if ma-close na ang circuit, so mo flow na ning negative kanang terminal, aw kaning negative nga mga particles. Kay di ba, they tend to attract to the positive side. So mo nang naay flow. And this flow creates what is known as current. Okay, current. And then mga to na siya sa hato na siya sa positive. So mo-attract na siya diri, ang electrons mo-attract sa positive. And then hantod nga sige ni og tuyok, sinig tuyok hantod nga mahurot na ning mga kuan diri. Mo nang there comes a time nga ang atong battery is wa na siya power tungod kay na-neutralize na, wala nay electron particles sa negative side nga mo kuan na pod, nga mo travel tungod kay nahurot na. Kay di ba gi-transfer naman ngadto sa positive side. So this is again the positive side, this is again the negative side. So mao na ang basic kuan sa battery. And of course, sa bawat travel sa negative, of course dili na ingon nga i-travel niya tara dito kay sa ato ang kanang circuit na magintay kanang device. So ang atong device siya po'y nagkaon sa abang electrons because of course this is energy. Okay, this is energy transformation, which is from the chemical energy from our battery into electrical energy and then into light energy sa atong bulb. So may transfer siya, meaning si bulb, which is our device, consumes electricity from the battery. So dili ingon nga unsay energy diri sa negative or ang tanang electrons mangadto sa positive, ang uban kay mangadto sa bulb para i-use up as an energy. Okay, i-transform into light then into heat. So mao nang naata atong gitakol diri ang power. Okay, meaning ang gi-consume nga energy per unit time sa atong bulb or sa atong device. Here in our example, bulb lang siya. So mo na as the flow of electrons from the positive towards the negative, may enter siya sa bulb, mao nang musiga ni nga bulb. So musiga ni siya and creating light and heat. So unsa man nato pag-quantify sa amount of power nga ma-consume niya. So power P is equal to the product of the voltage, okay? Voltage times the current VI. Now, nga nakaingon man tani, of course, since di ba as what I have told you, ang tubig nga nasa tangke is analogous sa atong electrical circuit. Di ba if you remember sa atong discussion in module 2 that the energy of the fluid is just equal to, or the work of the fluid is just equal to its pressure times the volume flow rate. Okay? So, di ba atong pressure in analogy sa atong electrical circuit, this one represents the voltage. And of course, kani siya ato ang volume flow rate. This one represents our current, VI. So that's why we have a formula for our power. Power is equals to VI. Okay? VI. In unit analysis, the voltage is in volts, and then the current is in ampere. So therefore, volt ampere ni siya. Okay, volt ampere. Or since this is power, the volt ampere is just equivalent to watts. Unya sa ato ang module to, di ba, watts is also equivalent to joules. This is joules per second. Okay, so muna siya ang formula sa power. And since we have Ohms Law, di ba? Namatay Ohms Law, balik ta diri kaning Ohms Law nga V is equal to IR. Now we can use this in order to derive another formula for power. Okay? So if we're going to let V is equals to IR. So we're going to substitute this V sa atong formula so that our power, mahimo siya ani, power is equal to IR times I, or that is I squared R. So again, same ra gyapon siya. Magamit niya siya if ever, if you're given an electrical circuit, then wala si voltage but you have resistance and current, then makasolve gyapon ka. And we can also have the last nga kuan, last nga kanang formula for power nga wala si kuan. Kay diri sa ikaduha wala man si voltage ari. Ay katulo is wala na pud si current. So unsa ang pag-eliminate ni current? Now maglet na pud ta diri. Okay, maglet na pud ta. Let the current is equals to voltage over the resistance. So i-plug in na pud ni ngadto diri so that we have the third form of our kanang formula for power. So power is equals to V over I, and we have I here, so that is V multiplied by V over R. So the power is V squared all over R. So we have three forms here. Can you see power is V squared over R, or you can have here power is equals to I squared R, and then we have ang pinaka root good nila is V times I, or voltage times the current. So muna siya ang kuan class. If we have a lot of devices here, so magamit ito ang ato ang analysis sa electrical circuits katong mga series and parallel. So we're going to talk that one later. So walay pangutana ni. Nakasunod ra class? Okay, nakasunod ra? Okay. So after Ohm's law, mo jump nta sa resistivity. So di ba from Ohm's law again, balik ta sa Ohm's law formula for Ohm's law equals V is equals to IR. So here ang usa sa mga parameter nga naa sa formula is kani ang kuan, kani ang resistance nga R. Okay, so ang kani resistance R, it depends upon the material pod, the material. Okay, nagdepende ni siya sa material. So mo nang ato ni siya isolve because kaning current and voltage they are directly proportional na magod in nature, because ang voltage nag-agad ra pod sa capacity sa imong battery or sa imong power source, and the current of course nag-agad ra pod sa kanang kuan pod sa capacity pod sa imong kuan, and also the resistance of the circuit. So here, since we're talking about resistance, so ato na pod kana incorporate ning gitawag nga resistivity. So unsam ning resistivity class? Actually kaning resistivity is mo na siya ang amount or the property of a material to kanang resist the flow of current. So kung taas og resistivity ang atong material, then mahug na siya nga unsa man. Di ba, if ang material kay mo permit siya og flow sa current, gitawag na siya kanang conductor. So kung ang material kay mo resist og flow sa current, unsa may tawag niya? Na may idea? Kung ang material kay mo resist og flow sa current, unsa may tawag nila? Unsa man na siya? Class, unsa man na idea? May idea wala? Napa mo? Unsa may kuan? Sa may indication kung taas og resistivity ang usa ka material. May idea? So kung taas og resistivity ang material, then makaingon ta that the material is an insulator. Okay? So tag-as og mga resistance or taas og resistivity, we are kanang makaingon ta nga kana nga material is an insulator. And again, resistivity and resistance are both kanang kwan different nga mga parameters. Kay ang resistivity, that is the property of a material, and the resistance, that is the amount of kanang kwan kanang kwan kanang magnitude na siya sa ka material nga mo resist og kanang flow sa current. So mao na siya. Mao nakalian niya. Again, ang resistivity is property na siya sa material, ang resistance dili na siya property sa material since kuan na siya kanang quantity na siya nga dapat sukdon. Okay, sukdon na siya dapat. And mag-agad pod sa iyahang length og sa iyang area. So meaning mag-agad sa kanang kuan, mag-agad sa other parameters kana sa material. So ato i-define ang formula for resistivity. So formula for resistivity. So it states that the resistance R, okay, ang resistance day nga ma-offer sa atong material is directly proportional to unsa man the area, the cross-sectional area niya. So this is the cross-sectional area all over the length of our conductor. Let's say natay conductor diri. Okay, natay conductor. Mana. So gi-zoom nato kuno hay ang usa ka portion sa wire. So usa na siya ka portion sa wire. So here kanatong wire, of course, na siya length. Our wire has a length, and of course it has the diameter, or in terms of area, this is its cross-sectional area. So meaning ang resistance sa ato ang material or our conductor is kanang kuan directly proportional sa ato ang kuan, ato ang kani di ay bali. Ang resistance nato kay directly proportional sa ato ang length, but inversely proportional sa ato ang cross-sectional area. Why? Because again, di ba, analogy sa tubig, if we have a current here nga mo pass through, natay current here nga mo pass through, okay, the current, kung ato ning padak-an natong area, so dako kay masudlan, daghay current nga mosud, di ba, kay resistance man meaning atong pugnan ang flow sa current. Mao man gamit sa mga resistive nga mga materials. So meaning kung taas pug kaayo ang matravel ni current, madugay pa siya kabot. So meaning if we have a greater length of our conductor, so taas kay taog resistance, mao nang directly proportional siya sa length. However, inversely proportional siya sa cross-sectional area. Kay if dako kay tag cross-sectional area, daghan kay current nga mosud. Okay, taas og current ang mo flow. And as you notice, di ba, sa ato ang mga wire nga nasa kalsada, kanang nasa gipangkuan sa mga poste, di ba? Dagko kay nang mga wires, of course, because they maximize the power transmission that is being transmitted from the source towards the residential homes. Mao siya dagko kay na siya mga cross-sectional area para ma-minimize ang resistance. Of course, di mo gina mawala. And here, mao siya ang analogy. So resistance is directly proportional sa length. Kay kung magkanag kataas ato ang kanang conductor, magkanam gina siya taas. So magkanam pug kadako ang ato ang kuan, magkanag kadako ang ato ang resistance. So since na naman tay relationship nga atong na-acquired, so in order to transform it in equation form, so we apply some proportionality constant. So that would be the resistance is equal to some proportionality constant, and we're going to let this one as rho, then L over the cross-sectional area. So this rho right here, kanya siyang rho, kaning rho, mo na siya atong gitawag nga resistivity. This is the resistivity of a material. So very unique kani siya because resistivity is a property of a material. Okay? So, kung dako kay resistivity ang material, so since they are directly proportional, kung dako ni siya, automatic mo dako pod ang value sa imong resistance. And of course, additional pa gyud, taas kay na ang imong conductor, taas po kag resistance. So mao nang kabantay mo sa kanang mga kuan, kanang sa wirings ninyo sa inyong kuan, laptop mong maong gagmay ka nag mga current nang naa sa inyong laptops or inyong cellphones kay gagmay po nag-wire nya tag-as pigi sila nipis og wire nya tag-as. So mao nang ang amount of current nga mo flow ana nila is gagmay ra pud tungod ini kay taas na ka og kuan I mean nipis kag wire, so that is smaller imong cross sectional area. Unya tag-as pa jud na sila, meaning ilang length kay mo stretch maybe half of a meter, so dako kay kaog resistance. If dako kag resistance, so meaning dakog chance nga imong pugnan ang current, so mo nang gamay lang ang current nga mo flow, gamay lang ang charge nga mo flow sa atong circuit. So basically mo ni ang formula sa kanha sa resistance. So ayo lang jud ni kalimtin ninyo class kani nga drawing. Kay dili na nagsugod ang tanan para ma-derive nimo siya. Again, of course, kung taas kag length, madugay abot si current. So that's why they are directly proportional sa resistance. Kaya again, resistance mo ginay mo pugong sa current and then its cross-sectional area. So kung imo ni padakan ang buho, automatic more chances nga daghay musud nga current. So that's why they are inversely proportional with resistance. Kay kung paggamyan nimong cross-sectional area, mudako yan resistance kay imo nang paggamyan ng ang diameter araaw gamay lang musud nga current. So ingana iya analogy class. And kanang since naman sila proportionality constant, so i-apply nimo butangan nimo another parameter, and this parameter is called the resistivity of a material, which is the property of a material itself. Property. So property ni siya ha. Unlike resistance nga masukod using this formula, or if you have a kuan measuring instrument, so masukod nimo siya. So nay pangutanan eh. Nakasunod mo class? Napa mo? Are you still following? Napa? Okay. So muna siya ang resistivity. Take note ang resistivity. And kung naka-notice mo, okay? Kung naka-notice mo sa atong kuan ha, ato ang katong sa previous nga slide, diba? We have formula for power. Power is equals to I squared R. Okay? So, mao po ni class ang implication kung dako tag resistance. As you notice, in our formula for power, I squared R, para po maka-appreciate mo say gamit aning, of course, gamit gini siyang mag-study of electricity. Para maka-appreciate mo, consider this formula for power. So, since the resistance is directly proportional to our power, meaning dako kag resistance sa imong circuit, dako kay kag konsumo. Okay? Meaning dako kag power. Dako kag power kan mo nang kung sa may resulta class kung mo taas imong power, meaning manginit, di ba? Manginit. So dako kag consumption sa energy. And good example ni ani is nakakuha na ba mo hair dryer? Class nakakuha mo hair dryer? Okay. So kanang hair dryer unsa may principle behind ana sa hair dryer? Na may idea? Na may idea na class? Actually, kanatong hair dryer, of course, that is an electronic device. Kanatong hair dryer class, so follow ninyo, nana ziyay gitawag nga nichrome wire. Familiar mo ng nichrome? Na siya nichrome wire or heating element. So atay drawing dira, it has a nichrome wire. So kana siya kaning green nga ang drawing. So na siya coil. Then of course, napagin na siya additional nga mga electrical components, but for the purpose of simplicity, so let's just assume nga we just model this one as a simple circuit. So na siya nichrome wire, and of course it has a source of power. Let's say ato isaksak, di ba? Isaksak mo ni hair dryer. So mo na itong power source, positive and negative terminal. So as the current flows, of course, di ba? Ang nichrome wire class, kanang nichrome wire, nana siya iyang kaugalingon nga kanang resistivity. So kaning nichrome wire, so kana siya nana siya resistivity. So nichrome, and dako kana siya resistivity class ang nichrome wire. Mo nang gamit gina siya sa mga heating element. So inyo na pang ukbo na inyong mga kuan dira, and napailain kaning nichrome wire makitaan kung mag-ukab mo kuan water heater. Na ubang water heater gamit og nichrome wire. Unya sa last nakaukab ko og rice cooker, pero di tanan. Na ibang rice cooker na nichrome wire. So inyo ukbon na mga coils dira nichrome wire na siya. And then after ani kaning nichrome wire, kabantay mo unsay purpose nganong gi-coil ni siya. Ini idea class. Inyo i-relate ari sa atong formula sa resistivity. I-relate nyo dire. What is the reason why gi-coil na siya kadaghan? Sa man class? What is the reason why namatay coil ari? Sa man class? I-relate ra ani kani. Resistance daw is directly proportional to the length over the cross-sectional area. Unsay pasabot? Nganong ato ni siyang gibubod og kapila? In order to what? Wala idea? Naratan awa. Balik mo sa kuan formula. Kani R is directly proportional to L over cross-sectional area. Unsa maday hinungdan nganong gi-coil man ni, gibubod man ni kapila para mo unsa man, in order to increase the unsa man. Mr. Pagas, Miss Pakanya, Mr. Bote. Unsa man nganong gi-coil man ni? Okay, and specifically unsa may mo increase nga parameter gikan sa atong formula? Not necessarily resistivity, but unsa may mo increase dire. Di ba kung magbubod ka og nylon or kuan, unsa may mo increase? Bisa kanilang tulo, the resistance, the length, and the cross-sectional area. So sa kaning tulo, asa may mo increase nila kung magbubod ka og pila ka beses? Mo increase ang unsa man? Kanilang tulo, focus only these three parameters nga akong gi-mention. The resistance, the length, and the cross-sectional area. Which of these parameters will increase if we are going to increase the number of turns or increase the number of coils? Unsa man? Kaajud? Obvious ra kayo. Wala jud? How about you, Mr. Bote? Wala? Wala gid? So, if we're going to increase, okay, the number of turns, mo nang gituyo gina nila sa mga water heater, gituyo gid na, it's not necessarily nga mo increase yung resistivity, because since I already mentioned you nga nichrome wire ni siya, and then diba again resistivity is a property of a material. So meaning kung unsa na iya resistivity mo na gina siya. So it is not necessarily nga coiling this nichrome wire many times increases resistivity. Okay? Di na siya ma-increase, but ang ma-increase ani is ang length. So in coiling this nichrome wire many times, we increase the length. Of course, di ba? Kung dagan kag bubo dira, mas taas na siya. So we increase the length L. So if we're going to increase the length here, unya na siya giving resistivity, automatic dako iya resistance. Okay? So increasing L would increase R. So balik taari sa ato ang power nga formula. If we're going to increase R at a given current, so na magi current nga mo-flow ana, then mo increase itong power. And power is closely associated with energy. So ang energy transformation ani is from electrical to heat. Tungod kay dako na resistance man manginit ni. So manginit ning nichrome wire, magsiga ko ni siya red hot. So mag red hot ni siya maunang namatay fan are sa ato ang hair dryer na nay fan. So mo enter ang air, then pag agi niya dira mo init ang hangin. So mo nang sa hair dryer ang buga kay init. Sabtan ra? Sabtan niyo class? Are you still following? Okay, so silence means yes. So let's proceed. So this one, problem number 1 for resistivity. So here, calculate daw the resistance of a wire of length 1.5 meters and diameter of 0.8 millimeters. The specific resistance of the material of the wire is 45 times 10 to the power negative 8 ohm meter. So again, I put kahadlok aning usam ning specific resistance here. Actually, this is the other term for resistivity. Resistivity ra gyapon na siya. Okay, we're going to draw the figure and write the data or mga data niya. So here we have a length of wire or length of a conductor. So the length here is 1.5 meters, and then the diameter here is, this one is 0.8 millimeter, and then iyang resistivity rho is equal to 45 times 10 to the power of negative 8 ohm meter. So mana siya, and then atong requirement niini, so we are required to solve for R, the resistance of this wire or this conductor. So solution. So this is a straightforward nga example. Straightforward na kay ni kay given man ang mga given man ang mga kanang data. So solution, the formula for resistance using the property of a material resistivity is equal to resistivity the length all over the cross-sectional area. And we know that since this is a cylindrical wire, so the formula for its cross-sectional area is the circle, pi over 4 d squared. Then substituting the given values, we have 45 times 10 to the power of negative 8. This is ohm meter. Then the length of the conductor is in meters, that is 1.5 meters, divided by pi over 4, and here the diameter is in 0.8 mm. So I convert na to into meters so that we have a consistent unit. So we have here 0.8 mm. We all know that 1000 millimeter is 1 meter. Then we're going to square this. So here, ma-cancel din siya. What's left is meters. Automatic, the denominator have meter squared. So the numerator is, we have also meter squared here, ma-cancelled. So therefore, ang last nato or ang ato ang dimension or unit sa atong answer is indeed ohms, which is a unit that represents our resistance. So let's simplify this so that we can arrive our answer. That would be 45 times 10 to the power of negative 8 multiplied by 1.5 all over pi over 4 times this one is 0.8 divided by 1000 squared. The answer is 1.34, so approximately 1.34 ohms. You can have this omega or kaning imo spell out yun ang ohms. So this is our final answer. Naipangutan na? Follow na class? Still following? Okay, I hope naka-follow. So, let's continue. Here, we're now going to answer problem number 2. So, in problem number 2, again, calculate the resistivity of a material of a wire whose resistance is 1.5 ohms with a diameter of 0.32 centimeter and a length of 80 centimeter. So, figure and data. Nanapod tayo wire. So, this is our wire. And then, it has a length of 80 centimeter. Take note gid class sa dimension para di mo masayop. And then, it has a diameter of 0.32 centimeter. And the resistance here, so the value of R is equals to 1.5 omega or ohms. So required here, requirements, so we are required to solve for its resistivity, that is rho. Okay, ang rho may gipangita ni ini. So solution. So here we know that the formula for resistance is equal to rho, the length over the cross-sectional area. Since we are to find for rho, then I'm going to multiply both sides by cross-sectional area over the length para makancel ni siya. So we have rho is equals to R cross-sectional area over the length. So here, we're going to plug in the given values. So, kay bawa naman ta, resistance is 1.5 ohms. So put here 1.5 ohms. The cross-sectional area is pi over 4, then this one is d squared, so our diameter is 0.32. Atos I convert into meter, cm, then 1 meter is 100 cm. So kana siya, squared na siya, all over the length is 80 centimeters. That would be 80 cm, then 100 cm, 1 meter. Yan class. And then unit analysis, so kung unsay makancel, so takitaan diri, so makancel ani cm makancel, kaning cm makancel. So in the numerator we have meter squared, here is meter, so therefore makancel pud ma meter na lang diri. So we have ohm meter. So the dimension for resistivity is ohm meter. Resistivity is therefore equivalent to 1.5 multiplied by pi over 4 times 0.32 divided by 100 squared all over 80 over 100. So the answer here is approximately 1.51. Approximately this is 1.51 times 10 to the power of negative 5 ohm meter. Wala siya. So gamay kaayo iyang kuan, iyang resistivity. So this would be our final answer. Pangutana. Ah, sige sige. So walay pangutana ni. Okay na? Ah, kana kana. Kana siya 1.5 times 10 raised to negative 5 ohmmeter na siya. So be careful yun kung mag-solve mo, dapat consistent mo sa inyong dimensions or sa inyong units. Okay na. Okay, so let's proceed. We're now on electrochemical equivalent. So in the electrochemical equivalent, basically kung ano siya, applied ni siya sa electrolysis nga kuan, marabag ang certain amount of certain amount of element kay kanang produce siya electricity due to some reaction with other other material or by the process of electrolysis. So ang ato mga element with the electrolysis nga process, so kanang di ba ang elements kana man sila mga electrons pod, so kana siya mo-produce na siya electricity. And in order to quantify this electrochemical equivalent, so we have our formula that is gi-abbreviate naman itong ECE. So we have ECE. Electrochemical equivalent is equal to the mass of our element. Okay, the mass of our kanang element, then the current. Okay, the current, and then multiplied by the time. Okay, so I mean kuan din siya, baliktad yan day. The electrochemical equivalent in terms of kan siya sa mass. So we have here, it's again general formula that is the mass of an element is related to the electrochemical equivalent, so that is ECE. And other books yan ang gikuan nga ECE is gi-abbreviate nila as Z, and then multiplied by the current times the time nga mi-take ang pag-react sa electrolysis. So kani siya, this one represents, so to label, this one represents the mass of our element undergoing electrolysis. So kana electrolysis more siya process na chemical reaction, then makaproduce ka og electricity, sama na siya. Then ECE more siya electrochemical equivalent during electrolysis. Then current, I, of course this is our current, meaning during electrolysis class nabatay current nga i-pass through ni para na ay reaction nga may tabo. And then of course this one is the time nga nakumpleto niya ang kadtong electrolysis nga process. So other books yan ang kanang gi-abbreviate ang EC as M is equals to Z I T. So man siya inyong hinumduman class. Mass, so mass unit analysis ta. Mass here is in kilogram. Then the current here is in ampere, and then the time here is in seconds. Diba? Kilogram equals ampere here is, that is charge per second, or we have here coulomb per second, then multiplied by second, so therefore coulomb na lang ni dire. Therefore Z here is kanang kilogram per kuan siya, coulomb. So therefore ang unit sa electrochemical equivalent is kilogram per charge or kilogram per coulomb. So mana siya. Mara yung himduman sa electrochemical equivalent nga formula. So again, mana siya ang kanang kuan, ang process in which ang atong element gi subject into electrolysis nga process. So again na, mana siya tawag niya electrolysis nga process. Electrolysis wherein atong gikuan, atong gi quantify kung unsay equivalent sa kaning reaction sa atong element in terms of its kanang electricity nga ma-produce. Okay, due to the reaction, of course makuha man to ilang mga charge particles katong electrons manggawas. So naay probability nga maka-produce sila og kuryente. So mao ni siya, gi-quantify aning mass is equals to the electrochemical equivalent Z multiplied by the current and multiplied by the time nga na complete ang kaning electrolysis. Okay, so walay pangutanan ni. So walay pangutanan, then let's have some examples. So here we are going to calculate the electrochemical equivalent of copper when a current of 1 ampere passing through a copper voltmeter of 1 hour liberates 1.2 grams of copper. Okay, here natay voltmeter, so passing through a copper voltmeter, so basically mo na siya electrolysis nga aparatos. So ano siya, passing niya na siya copper solution ni copper solution. So here naka-generate daw siya, so we have some mass here. Naka-generate siya og 1.2 grams of copper, that is Cu. And then what else? So during this electrolysis kanang process, natay gipaagi nga current, that is I current of 1A, that is 1 ampere. Okay, so mana siya, and then napadri for 1 hour daw, di ba? Nadri for 1 hour. So therefore the time for this process takes 1 hour. So mana siya mga important nga mga data sa atong kinahanglanon. Then we're going to write the requirements here. So required is we're going to solve our electrochemical equivalent, that is ECE or the Z. Okay, the Z. So let's solve for this one. Solution. That is, the mass is equal to Z, the electrochemical equivalent, multiplied by the current times the time. Since we're going to find Z, so we're going to divide both sides by IT. Divide na to. So this one will be cancelled out. So what's left is we have Z is equals to the mass over IT. Then plugging in the values. So mass is 1.2 grams, or let's have our answer in kilograms. So that is 1.2 grams, that is 1000 grams, 1 kilogram. Divide by the current here is ampere, that is 1 ampere. Then ang ampere pod is equal to 1 coulomb per second, para in terms of coulomb na lang po na diri. This is 1 coulomb per second. Then at 1 hour, so 1 hour, and since in second ba ni, so be consistent, so convert hour into second, that is 1 hour is equivalent to 3,600 seconds. So, ang unit analysis niya ni makancel ng grams, second and second, and hour. So, what's left is kilogram per column. Muna siya ang answer sa atong or dimension unit sa atong um, electrochemical equivalent sa copper. Z is equals to, simplifying, we have 1.2 over 1,000 divided by 1 times 360, 3,600. So our answer is 3.33. That is 3.33 times 10 to the power of negative 7. That is kilogram per column. So gamay kay in terms of man, in terms of kanang kilogram man siya. So naipangota na class. Pangota na. Wala na? Okay. So, proceed na lang ta sa electrical circuit analysis. So, for electrochemical equivalent, straightforward na magandang formula, and then you can also you can read again the formula on the sa module na on the module, that is module 3 oh, module 3 lesson 1. So let's jump na sa electrical circuit analysis kay huwag man na siya ang importante dire. So in analyzing electrical circuits, we need to know of course the configuration for each circuit, and then we're going to start with series circuit. So when we say series circuit, ang load ani niya, okay, since di ba ang circuit comprised of power source, connecting wire, and the load. So at example ganiha previously, the bulb here, we assume that our load is a resistor, so meaning it possess some resistance. Of course kana atong mga bulb na naging resistance, so that's why everything or every device we can model that one as a resistor. So let's start with the series circuit. So ang arrangement niya ni or ang format niya ni is this one. So for a series circuit, we have a power source, then natay kanang resistor, then resistor 3, so on and so forth. So here we have our power source, di ba? This is our source of kanang source of power. So that is our battery, and then natay gipossess ani nga voltage. So natay voltage nini, and of course for a series circuit class, as you notice, di ba? Analogy nato is ato na siya i-model as a kanang water system, meaning pipes kunuhay nato ang connecting wires. Okay, let's say kani connecting wires muna siya. This is our connecting wires. Kumbaga mura siya tubo. Kana siya moda ang ato ang resistor. Okay, kaning tulo that models our mga devices. Diba atong mga devices na gina sila nag-offer gina sila resistance. So these are resistors. Naka-arrange siya in series. Why? Because diba naka-series siya, meaning ang end sa usa may connect sa front, then ang end to end connection ba end sa usa mi connect sa end sa usa, ang end na pud sa usa mi connect na pud sa other end sa usa. So muna siya ang series. And then let's label this. Okay, let's label this one as R1, R2, and R3. So atong source kanay volts, and then for a series circuit class, di ba ingon man ko ato na siya i-model as a water pipe. So if natay source nga power dire, mo flow daw siya ri, mo flow dire. Okay, so moagi aning resistor 1, pag mag resistor 1, muka na pud hawa, moagi resistor 2, moagi resistor 3, balik na pud sa power source. So here we can say that we have uh, uniform, okay, we have uniform current. So meaning out from this series circuit we can quantify the voltages here. We can quantify the three parameters here. So for the three parameters we have voltage, current, and resistance. Now let's start with the current. So for our current I. So ang total current class, that is I total, is just equivalent, okay? Equivalent na siya sa current nga may agi ni R1, equal po siya sa may agi ni R2, equal po siya sa may agi ni R3, meaning the currents are the same throughout. Even mo agi siya resistor 1, equal lagi hapon kay naka-series man siya. That is for current. Again, for a series connection, ang current for each resistor are equivalent to each other. They are the same. Kaduha, we have voltage or kanan sa resistance. Or mag-anata sa voltage. Sige, voltage na lang palita ko. Voltage. Okay. So, giingon man dire. Okay. The total voltage, that is V total, is equal to the total current I total times the total resistance R total. Okay, but we don't know yet kung say total resistance, but we know the total current here, diba? The total current is either I1 or I2 or I3. Anyways, the same man sila. So if wala pa dira, then proceed ta ni resistance. So for the resistance class, since it is connected in series, the total resistance R total is equal to the sum R1 plus R2 plus R3. So maora gina siya class. The total resistance for a series circuit is just the sum of the individual resistance R total. So if that is R total, then going back to our voltage nga kuan, going back to our voltage nga problem. So nakasunod pa mo? Are you still following, class? Are you still following? Okay. So, wala gid mo ani kasugat sa inyo hanggang senior high. Okay, nakalimtan na. Sige, sige. So, mano siya ang derivation ani niya. So, total voltage is I total times the total resistance. So, di ba? We all know that the total resistance is just the sum. So, ako na siyang substitute ari. So, distributing this, so we have I total R1 plus I total R2 plus I total R3. Here, ang I total na may R1 no, di ba? I total is just equal to any other currents that passes through either of these kanang resistors. So, for R1, pwede po na ako bubutang diri si I1, I1 R1. Pwede na ako say partner. Why? Because I total is just equal to any of these currents for any resistor. Then, plus I2 R2 plus I3 R3. So, nahibuong mo nga nung gipang usab-usab na ni sir nga nung nailham ni current. Anyways, kaning I1 magud og I2 and I3 same magina siya. So therefore, ang total voltage di is just equal to the voltage at resistor 1, di ba? Ang IR is just equal to voltage, di ba? Voltage is IR ba ya? Then plus this one, I2 R2 is just V2 plus I3 R3, that is V3. So therefore, for a series circuit, the total resistance is just the sum, and also the total voltage is just the sum, but however the total current is equal for every resistance, for every resistor. So mara na inyo yung duman kaning tulo. So this is for series circuit. So nakopya na, kaya ako na-erase na siya. Let's move to let's move to parallel circuit. So move ta sa parallel circuit connection. So again, ato na po ikuan ang voltage, current, and resistance. So considering again a circuit that is in kanang kuan parallel arrangement. So we have a power source here, then nata resistor ani, then kaning resistor 1 ato siyang i-parallel og another resistor. So resistor 2 parallel pud nako sa resistor 3 R3. So again, mao na pud natong power source. This is our power source. And then atay of course voltage V. And then here class, if we have a total current here, nagsugod tag total current diri pag abot ani nga junction class, mo split na ang current for parallel, di ba? Mangadto siya ni R1. This is I1. Then ang remaining mangadto pod, mo split na pod siya padong ni I3 and then hadto ni I2. So here, wala nagka-split na. So therefore, for kanang parallel circuit class mga usab na po dari. And then as you notice class, kani si I3, okay, kita niya si I3 mo pass ari. Pagsugat ni I3 magsugat ni sila ni I2 diri ang junction. So therefore kaning gawas diri is equal to I2 plus I3. Si I1 na pod, may ari na pod ari, may sugat sila ni I2 ug I3. Now ang labas is the sum of I1 plus I2 plus I3. And mao na mibalik nga to sa source. So therefore, in our first parameter, that is for the current I, we can say that the total current I total is just equal to the sum of the individual currents that passes for every resistor. I1 plus I2 plus I3. Okay, kung yung kita ng diagram. That is for current for parallel. And for voltage, okay, voltage for voltage V, the voltage for parallel opposite siya sa katong sa series, because here the total voltage is just equal to the individual voltage for every resistance. Equal ra ang sukod ana. Okay, V total is just equal to the voltage at 1 plus voltage at 2. Equal din siya, sorry. Di na siya addition. V1 equals V2 equals V3. Nga naman, di ba ang voltage kay point to point ni siya. So, voltage array o across array. So, meaning, same man sila ni nga linya. So, meaning, usare voltage ni ini. So, that's why they are the same. The total voltage is just equal to either voltage 1 or voltage 2 at the resistor 2 or voltage 3 at resistor 3. Now, ang pinaka inyong tigaman for parallel is the total resistance. So, let's go to the resistance R. For the total resistance, so ito yung nga R total is equal to, diba, the formula for resistance is V over I, diba? So, that is the total voltage all over the total current. And we all know that the total current, okay, we all know that the total current is equal to I1 plus I2 plus I3. So, okay ba mata na? I1 plus I2 plus kanang kwan I3. So, here, ngayon ta, V total, tandiri, V total over I1 plus I2 plus I3. And here, kana makaingon pud ta, or in order to derive for the kanang total resistance, we can also use, okay, diri pwede po tayo maka-use the formula for current. Formula for current, diba? In current, that is I total is equals to I1 plus I2 plus I3. We all know that the total current is just equal to voltage, the total voltage over the total resistance, equal to I1. So, unsa may I1? That is V1 over R1. Diba? Kaya ang formula sa current is V over R. So, that is voltage at 1, resistance at 1. The same thing with I2. Voltage at 2, resistance at 2, plus voltage at 3, resistance at 3. Here, diri a class, diba V1, we all know that V1 equals V2 equals V3. Ato na siya ma-base ari niya for voltage for parallel connection. So therefore, these are all the same. That is just equal to the total voltage. So therefore, that would be V total over R total is equal to, ato na siya extract, may mo siyang V total multiplied by 1 over R1 plus 1 over R2 plus 1 over R3. Here, common man si V total, then we can kanang eliminate this one. Makancel na siya kay if we're going to multiply both sides by 1 over V total, mawa na siya. So, what's left di ay here is 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So, na gets ninyo? This is now the formula for the resistance for parallel circuit, parallel connection. So, walay pangata na? Walay pangata na, class? So, if walay pangata na, then let's proceed to some example. So, I have here an example of a series circuit na problem. So we have this problem comes from a survey nga college physics. So here we have four resistors arranged as shown in figure 18A. So kani siya kaning first figure. Then find A the equivalent resistance of the circuit. So diri ato pang lista mga required. So required in this problem for letter A, we're going to require or we're going to find the equivalent resistance of the circuit, that is the total resistance or total. For B, the current in the circuit if the closed circuit terminal voltage of the battery is 6 volts. So that is the current of the circuit, that is I total. Okay, so the circuit naman if nakay at voltage of 6, that is the voltage at the power source. So ato ang battery. Katulo C, calculate the electrical potential at point A if the potential at the positive terminal is 6 volts. So at the positive daw, again voltage is point by point. So that is voltage at the positive terminal to A, or that is just simply equal to voltage at resistor 1. Kay mao man yang gi-cover up daw kani dire padong dire. So therefore kani nga voltage ay hanggi pasabot. So that is just equal to the voltage at resistor 1. And then next for letter D, suppose open circuit voltage of or EMF E is 6.2 volts. So meaning napatay laing gi-assume nga if natay additional EMF ka 6.2 volts, then calculate the battery's internal resistance. So meaning napatay laing voltage nga gi butang. So and then we're going to solve for the resistance of the battery, that is R battery. Then solve R battery at E is equal to 6.2 volts. Then next letter E, what fraction F of the battery's power is delivered to the load resistor? Okay, so E in siya, what fraction of the battery's power is delivered to the load resistor? So fraction F, this is percentage of the power nga na-deliver daw ngadto sa mga resistors. Kaya of course nagbiday sariling power ang ato ang battery. So solution, here we are going to start by solving the total resistance of our circuit. So for letter A, since this is a series circuit nga kanang connection, then we can say that the total resistance is equal to pila man to class. So tayo formula for series. What is the total resistance? Sa to class, kinamdom pa mo? Unsa man? The total resistance is just the sum of R1 plus R2 plus R3 plus R4. Here R1 is 2 ohms, 2 plus R2 is 4 ohms, plus R3 is 5, plus R4 is 7. So ohms ni sila tanan. So the sum is 4 plus 2, 6, plus 5, 11, plus 7, 18. So therefore this one is 18 ohms. So the total resistance is 18 ohms. So na tayo usa ka answer. Total resistance 18 ohms. Then let's proceed to letter B. So for letter B, what would be the total current if our source voltage is 6 volts, so that is a series connection gihapon, series connection man then I total. So I total, the formula for I total using Ohms law niya, so that is total voltage or the source voltage ni siya all over the total resistance. So what is our source voltage? Again, given man that is 6 volts. 6 volts na. So we have here 6 volts all over the total resistance is 18 ohms base ato diri. So therefore this one is 6 over 18. Okay, 6 over 18, 1/3. Okay, 0 or 0.33. That is 1/3 ampere. 1/3 amperes. So mo na siya ang total current, 1/3 ampere if our voltage source is kanang kuan 6 volts. So nga ta for letter C. For letter C, calculate the voltage across resistor 1. Okay, that is V1. V1 is just equal to, di ba, formula for voltage by Ohm's law is I1 multiplied by R1. So we are given resistor 1, ang resistance niya, then I1, syempre we'll know that I1 is equals to I2 hanggang I4, which is the same as the total current. Since we already solved for total current, then masolve na po ng letter C. So for letter C, that is equal to I total R1. Again, for series ang I1 is equivalent sa total current. So here, total current is 1/3 amperes, so 1/3 A, multiplied by the resistance of resistor 1, that is 2 ohms. Therefore, the voltage here, di ay, V1 is equals to answer times 2, 2/3. So that is 2/3. This is 2/3 volts. Muna siya ang potential difference across resistor 1. Muna gipangita nato. Letter D. So for letter D. For letter D, what is the resistance of battery if we have an open circuit with a source of EMF of 6.2 volts? So here, ato i-treat nga kanang kuan na ay resistance ng battery. So here we can iterate the figure. So let's say this is our resistor. Kaning combined na niya, that is resistor from 1 to 4, that is equal to 18 ohms. Or as you can see the figure, kanang ikaduha letter B, gi-combine na niya. So here, since we have an open circuit voltage, so assuming ang kaning atong 18 ohm resistor naka-series biya ni siya sa atong battery, di ba? And then since yun man diri nga na internal resistance ng battery, then ato na po i-calculate na po R ang battery, R battery mo na atong gipangita. And we all know that the voltage across this battery is, di ba, katong V nato is equal to the total voltage, that is 6 volts. And the open circuit daw, so mo na siya ang voltage diri, that is V is equals to, or E, kani ang given diri nga E, so atibutan diri E here, E is equals to 6.2 volts. As you notice, again, this is analogous to another source na pod. This is analogous to another source and E2 resistor arranged in series. Maragid gihapon na siya. This is our E, this is our resistance from 1 to 4, katong kaganiya, and then mo na ang resistance sa battery, wherein the voltage across this will denote that one, that is V sa battery is 6 volts. Here, we're given E and we are to find R na lang sa battery. So, here, ang lacking man gud dira is the current. Okay? So, we don't know the current here. But, again, going back to our concept sa series, diba, in series, that is, for series, we know that the total voltage is just equal to the sum of the voltages in each resistor. That is voltage at resistor from 1 to 4 plus voltage of the battery. So here, the total voltage here is the E, kaning E. So E here is 6.2 is equal to the voltage from 1 to 4. What taka ka na ni? What taka ba ani? But we all know that the current here is iba man ta namtay given in current kana siya, di ba, ang nag-circle ano nga current is I total, that is equal to 1/3 ampere. Okay, 1/3 ampere na siya. And we all know that the voltage across 1 to 4 is pilar good to, that is I total multiplied by the resistance, the total resistance nga itong nakuha ganiya, that is the resistance from 1 to 4 plus the voltage on B, that is I total multiplied by the resistor of the battery. Okay, so wala siya. And here, we are going to solve for we're going to solve here for the resistance of the battery. So ato i-solve ang resistance sa battery. So here, R battery man na siya, kani R battery. Kani, so ato na siya i-transpose on the other side. Okay, ato na i-transpose on the other side. And then, solve for the resistance of the battery. So that is R battery is equal to 6.2. Okay, this is 6.2. Then minus I total R total all over I total. Here class, kani siyang I total of R total, this one right here, kani siya, this is just equal to the total voltage kanina, that is 6 volts, diba? This is just equal to VB. This is just equal to VB. So therefore, this would now be equal to 6.2 minus 6 volts. So volts, naka-volts na sa 3 volts divided by the total current is 1/3 amps. So therefore, simplifying this, we can now solve for the resistance of the battery. That is 6.2 minus 6 divided by 1/3. The answer is 0.6. Here, giingon din nga the internal resistance of the battery is 0.6. So mana siya class. And since we have internal resistance of our battery, so we also have power for our battery here and also for the power of the resistor. So mana siya gamit in order to solve for letter D, for letter E. That is the percentage, diba? The percentage of the power na kuno na deliver sa battery with respect to its kanang kaugalingong power. So diba, efficiency F is equals to power delivered sa resistor, power delivered all over power sa battery itself. So ang power nga na delivered class is equal to the kanang kuan, is equal to the kuan the square of the total current, that is I total square, di ba nakinduma tong I squared R and R total. That is the power nga delivered nga to sa upat ka mga resistors. Ang power sa battery is just equal to um, actually the voltage of the battery, that is voltage of the battery squared all over the resistance of the battery. So, pwede ka siya. So here, the I total is 1/3. Substituting 1/3 ampere squared times the total resistance is 18 ohms divided by the voltage squared of the battery, that is 6 volts. 6 squared all over the resistance of the battery, that is 0.6 ohms. So the answer is unitless since percentage naman siya. So pila ka percent daw ang na delivered. So that is 1/3. So 1/9 na ni kay mas square naman sa numerator, and then times 18 divide by 36 over 0.6. So the answer here is 0.03. Okay, 0.03 ra. So that is 0.03, or that is in percent. Okay, in percent that is 3%. Okay, so muna siya to ang answer class so far. So na question. Now may question ano regarding ano tong kan? Do you have a question? Okay, wala. So let's proceed to the next nga circuit, ang parallel nga circuit. So here we have three resistors are connected in parallel as in figure, as shown in the figure here. So natay R1 3 ohms, R2 6 ohms ang middle, and then on the right side 9 ohms ay katulo. A potential difference, so again kaning potential difference, this is just the same as the voltage of the source of 18 volts. So nara diri 18 volts is maintained between points A and B. So A and B. So therefore the voltage at these 2 points is 18 volts. Okay, equal man siya. And then next, find the current in each resistor. So ang required dire, again, so what na itong required A, that is find the current in each resistor. That is I1, I2, and I3. Tulo ka buo kay tulo man ka resistor. For letter B, calculate the power delivered to each resistor. So B, power at resistor 1, power at resistor 2, power at resistor 3, and the total power. For letter C, find the equivalent resistance of the circuit. So C, that is equivalent resistance, that is R total. For D, find the total power delivered to the equivalent resistance. So power using the formula of R total. Okay, so solution. So una nato ato i-solve ang I1, I2, and I3. So for letter A, for a parallel connection, di ba we all know that the total I1 is equal to V1 over R1. Masa may V1 class? Sige daw. Di ba for a parallel circuit, di ba ang total voltage is just the same as the voltage for each resistor? So meaning we can say that this one is just equal to the voltage at the source, or the V total over R1. So therefore this is 18 volts divided by R1 is 3 ohms. So therefore this is 6 ampere. So natay usa I1. Next for I2, for parallel, that is equal to V2 over R2. That is the total voltage, or the voltage at the source. Therefore this is 18 volts. This is 18 volts divided by, ang R2 nato is 6 ohms. So this one is 6 ohms. Therefore this is uh, 3 amperes ang I2. The next I3, that is V3 over R3, and here V3 is just the same with V2 and the V total. Therefore may mo siyang 18 volts divided by R3 is 9 volts or 9 ohms. So therefore this is 2 amperes. So we now have I1, I2, and I3, and this one is for letter A. Let's proceed to letter B. For letter B, we're going to solve for the power at resistor 1, 2, and 3, including the total power. Again, ang total power is kung siya additive na siya, so meaning that is the sum of the individual powers across the resistor or for each resistor. So ang power additive na siya, class. Kung nakay power nga nahatag sa resistor 1, i-add po na siya sa power sa resistor 2 o sa resistor 3. Labi na kung naka-series. For series, mo na siya. And then here, we're going to solve for the power for each. So P1 that equal to I squared R, or I squared R1, or you can have V1 I1. Kani bahala, same again siya. So that is equal to, here I1 is 6 ampere multiplied by the resistance of 3 ohms. 6 squared na siya. So the answer is 36 times 3. That is 108. So this is 108 watts. Again, don't forget to write the unit. 108 watts. Kani siyang P2. This is I2 squared R2. So this is 3 amps squared. Then ang R2 is, call me siya 6 amps, 6 ohms. This is 3 times 3, 9 times 6, 54 watts. Then P3 here is equals to I3 squared R3. So this one is I3 is 2 amps squared times R3 is 9. Ang R3 kay 9 ohms. So 9 ohms. This is 2 times 2, 4 times 9, 36 watts. So therefore ang total power P total is equals to P1 plus P2 plus P3. So isum up na nato, that is 108 plus 54 plus 36. The answer is 198. So therefore this is our total power, 198 watts. So these are our answers for section B. Let's proceed to section C. So section C, R total, the total resistance for parallel. Okay, parallel man siya, parallel circuit. Okay, total resistance for kanang parallel circuit. So for parallel circuit, we have, masaragod to? Nakinamdam pa mo? What is R total? Is it just the sum of the individual resistance or lahi? Unsa man to? Same ra ba? Sum ra ba sa R1 plus R2 plus R3 or lahi? Di ba lahi mag-formula no? Di ba for parallel circuit, di na siya sum sa individual resistance. For parallel, that is 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So here, that is 1 over R1 here is 3 ohms, so that is 1/3 plus 1/6 plus 1 over 9. Sum up na nato, 1/3 plus 1/6 plus 1 over 9. The result is 11 over 18. So 11 over 18, so that is our 1 over R total. And taking the reciprocal of that, so that we can have R total equal to 18 over 11. Okay, 18 over 11, or that is equal to 1.64, approximately 1.64 ohms. So mana siya ato ang total resistance kani siya. Now solving for letter D, that is the total power using R total. So using R total, we can have the total power that is equal to the total voltage at source all over R total. That is equal to the total voltage here is 18, di ba? 18 volts muna. So that is 18 volts squared all over the total resistance is 18 over 11 ohms. So the answer here, 18 squared divided by 18 over 11, the answer is 198 watts. So 198 watts. As you notice, same ra sa atong nakuha ganiha, because of course ang power anin the same ra gid na siya. Lahi lang ang pamaagi. So naipangutan na. So far naipangutan na ni. So wala. Okay, so if wala, proceed ta sa next. So this is an LED circuit nga problem. So kani siya, this is very important klasa kay mo siya ang real application good sa electrical circuit analysis. So tudloan to mo, especially kung mag-hook up mo og kanang power source, power supply, then na may LED, then unsa kahay imo idagdag nga resistor para mosiga siya ug di siya mobuto. Kay basin og mobuto or masunog, mao man na siya ang problema. So let's say na kay battery. Kunya ganahan ka kanay mo LED nga bulb bago niyong pinalit is musiga ni. Dapat musiga ni siya. So hatagan ta mo hatagan ta mo og kanang idea, insight para maka light up mo og kanang LED properly. Kanang mga small LEDs nga mga bulb, so makasiga na mo ani without damaging the LED and also the resistor. Kay siguro ang uban maka timing lang ilang mabutang resistor kay mo match. Anyway, kuan magod kung dako nga resistance inyo ibutang, musiga gyapon siya pero hinay. So kana itudo ninyo kay musiga siya just enough nga di maka-burn, di maka-create og kanang fire. So here, this is our LED. LED. So ang LED, na siya yung mga different colors. Na red, blue, green. And then here, we have a resistor. Of course, gitawag ang resistor class. Actually, sa circuit, okay, resistor. This is a current limiting resistor. Current limiting. Nga naman, di ba, ang resistor, ang gold resistor kay is to limit the flow of current. So here, para di kay bunog atong LED, okay, kanang para dili bunog sa LED, so dapat natay resistor para mupugong nga dili masunog. Mo na siyang gitawag nga current limiting resistor. Kay siya, instead nga siya ay magsuyop sa LED sa power nga nasa atong battery, suyopon pug apil ni resistor. Mao nang mugamay na lang nga dili kay maapektuhan og insakto tong LED. So here we have a resistor. So going back to our problem, ingon siya diri ang kani siya balikta. So if na lang kay wire, ginabaligta sa akong example diri nga figure. Kung na kay wire class, na kay battery, most commonly ang battery, ang voltage nila kung na kay single A nga battery, that is 1.5 volts or 3 volts, and of course na po kay 9 volt nga battery, na po kay 12 volts nga battery. Okay, pwede magkuan og 9 volts in series with 3 volts nga battery, so you can have 12 volts. So kung na kay battery, na po kay LED, na kay wire, na kay resistor, so makapasiga na kag LED properly nga bright siya o di siya masunog. So here mo na siya ang kaninga problem, mo na siya kanang mutudlo sa inyo sa pagpasiga. So here we have 3 LEDs, red, okay, hada ko na tayo tulo ka LED. Let's say this is our power source, 3 LEDs. So let's say this is our first LED. So muna na ito i-draw sa LED, ikaduha, then ikatulo. So 3 LED, red with forward voltage of 1.8. Again, for every LED class, na sila gitawag nga forward voltage. So this is red. Okay, para nindot, ato siya ilisidan. So this one, red nga LED. This is red LED with a forward voltage, meaning voltage across this LED is equal to 1.8. We are going to denote this as VR, meaning voltage on this red LED. So VR. And then you can also find this. Anyways, gikuha man gini nako sa iyang data sheet. So kada LED class kanyang paliton na siya data sheet and standard na for all. So here, pwede kani gyud yung gamiton gusto niyo magpasiga. Kani tanang red LED range sa iyang forward voltage is 1.8. So pasabot aning forward voltage class, mura gyud na iyang minimum voltage para mosiga. Kay ngano man, if you are below that voltage, di na mosiga mong LED pod. So mura just enough nga makapasiga kag red LED. Okay, mana yung forward voltage nana sa spec sa red LED, mostly around that value. So pwede nimo. Next is green. So naitay green LED. So this is green nga LED with a forward voltage that is VG na lang, 3.5 in volts niya. And then the last one is the blue LED. So blue LED. This one is our blue LED. That is VB is equal to forward voltage of 3.6 volts. Of course, kaning mga LED class, again, as what I have told you, tanang mga gamit na gana siya resistance. So meaning, napod ni sila inherent gamay nga resistance. Kaya na gina sila resistance. Diba kay tanang load, whether mapa-LED man or wala, ma-represent na nato, ma-model na nato as a resistor. So here connected daw ning tulo with a resistor R. So again, di ba, sa mga usual circuit na ginay current limiting resistor. So mao ni siya. Resistor R, walay gihatag pa. This is a current limiting resistor. Okay, R. Here, natay source with a voltage source with a voltage source of 12 volts DC. So direct current. Ayaw na isaksak sa AC kay buto gini. So sa 12 volts DC lang. So muna tong power source natay tulo ka LED, then naay usa ka resistor. So ang gipangita is calculate the minimum value of the resistor if the current flowing on the circuit does not exceed 5 amperes or at most 5 lang. So here, naritay current nga may flow. So we have a current nga may flow along these LEDs and the resistor, and this is I equals 5 amperes. Class, nakoy question ninyo, is it true nga equal ra ang current nga mo pass for every LED? True or false? Unsa man? Is it true nga ang current nga mo pass through sa red kay equal pud sa current nga kanang kuan may pass sa green ug sa blue? Sakto ba or dili? False. Nganong false man? Ingon si Archiles nga false daw. Like, dili pareha ang mo agi nga current sa red, sa green, o sa blue. Dili siya pareha. Unsa man? Sure na, dili pareha gyud? How about si Miss Pakanya? Unsa man? Pareha, dili? Dili pareha? So again, di ba kani, mura po ni sila og series connection, di ba? Unsa man toy current sa series connection? For a series, di ba? Nag-series man ning red, green, blue ug ang resistor. Unsa man toy current for a series circuit? So unsa man to siya? Pareha. Okay, pareha di ay. So pareha. Again, ay to kalimti. For a series connection, pareha ra ang current. So ay gid kalimti. So therefore, ang current nga moagi sa red, ang current nga moagi sa green ug sa blue pareha ra. So ay gid to kalimti akong analogy nga pura siya water pipe nga kung unsay musud sa red mugawas niya, musud na pud ni green mugawas, musud ni blue mugawas, musud na pud ni resistor mugawas, mubalik sa battery. So meaning pareha sila current. Di pareha sa parallel nga matunga mo split. Mga to spikas, mga spikas. So here, same ra. So solution. In order to solve for R here, what we need to do is, of course, so what nimo? R is equals to, from Ohms Law, that is V sa resistor all over say current nga may pass dira. But we all know, okay, this is Ohm's law. But kay baw man ta, but for series, the current nga hipas sa atong resistor is just equal to the total current, right? Which is equal to 5 amperes. Mo biya na sa ato That is 5 amperes. Now, naa na tay current but we don't have the voltage on this resistor. So what man taan ni? What we need to do is, okay, in series circuit ta pod. So in series we all know that the total voltage, that is V total, that is also the voltage at our power source. Here 12 volts DC ta. The total voltage sa series is just equal to the sum of the individual voltages. That is the voltage nga naa ni red LED plus the voltage ni green plus the voltage ni blue plus napay usa voltage ni resistor. So nadoble naman ning RR, so rest na lang ni voltage sa resistor. So here given man ning tulo, given po ng total, so makasolve ta aning resistor voltage kaning Vres. So i-transpose na lang ni on the other side ning tulo. So therefore we have here the resistor voltage. V resistor is equals to V total minus V sa red LED minus green minus blue. So that is 12 minus 1.8 minus 3.5 minus 3.6. The answer here is, so answer diri equal na siya sa 3.1. So therefore ang voltahe dahil sa resistor R is 3.1 volts. So naa na ta. Mo na itong gamiton, i-plug in ngadto sa atong equation diri so that we can solve for R. So solving for R, we now have R is equals to the voltage on that resistor is 3.1 volts based sa atong na-solve divided by the current there. The current there is just equal to the total current, that is 5 amps. So therefore, ang atong kailangan nga resistor dahil para di mo buto ang atong mga LEDs or para masiga silang nindot, that is 3.1 divided by 5. The answer is 0.62 ohms. So 0.62 ohms. Okay, so pamili di ay mo og kuan. Mili ra mo og kanang resistor nga 0.62 ohms or higher. So kung ma-higher pa mo ana, mo reduce na ang brightness sa imuhang LED. Now kung mo lower mo ana, what happens class? Sige daw. Kung magtaod ko class nga less than 0.62 ohms, what would be the possible effect nga mahitabo? Masaman, if mo gamay ko sa 0.62, let's say magtaod ko og kuan, magtaod ko og 0.5 ohms, unsay what would happen to our circuit? Unsa man class, what would happen to our circuit if magtaod ta og resistance which is smaller than what we have calculated here, di ba? Diri 0.62. What if mo lower ta ni unsay may tabo sa atong circuit? Possible nga may tabo. Unsa man, Miss Pakanya og Mr. Albarico? Di musiga. Ngano di on musiga? Kay ubos og resistance. Okay, actually, ang di musiga is the other side, which is kung magkaanam tag kataas. Kay di ba, remember the principle of resistor. Ang resistor, ang purpose diri kay mo limit sa current. So kung patas-an ni nato ang resistance, I mean, sakto kasi mong answer is in some ways. Kay daghang way condition ni ani. kung taasan nato og resistance manggod kani, taasan nato value, mahitabo is muhina yung siga hantod maka-feel ka wala gid misiga tungod kay dako ra kayong gibutang nga resistor. Ang kana pong di mo siga tungod kay hingbuto. Ganina di siya musiga tungod kay wa na ang brightness niya bali ng gamaya. So ang kung ato i-lower ang pinaka straightforward nga answer ani ko ato i-lower ang iyang resistance value is that mubuto. Mao nang masunog ang imuhang kuan. Masunog ang imuhang una ani kay moaso ang resistor. So naka try na mi ani sa mong project. Aso ang resistor kadugayan ana is may buong lang kang ang LED. Ang LED class di gina magsaba. Di na siya pareha sa kanang capacitor buto man gyud, pupaka man gyud. Ang resistor imo na manotice kay mo aso masunog. Ang LED kuya ra kina siya makuan kay mo burn out na ang iyahang sud nato marag film dito. Mo pop ra to pero di ka makabati og sound. Makabantay lang ka, di na gina mo siga, imo check di mo siga. Pero kung imong kitaon, mag-itom na ng tunga ni niya, automatic na burn out na. So manay mahitabo kung ato i-lower ang kanang resistance. Okay, so kan kini siya kung inyo ni apply sa tinud nga kinabuhi, gamit kini. Labi na maghimo mga projects, moro nimong gamiton, mag-drawing na kag circuit. Let's say magkuan ka nga mag-create kag project nga kanang mo automatic siya og paong kung mo gabiin na, di ba? Magamit makaana gitawag nga photoresistor. So resistance gyapon na siya dira. Imo ra gyapon i-calculate kung unsa nga threshold nga mo paong ni ang imuhang LED hinig mubuntag na. So imo ra i-calculate nya na kay available nga source of voltage. So mo ra nimo gamiton gid, series connection na gid siya, basic. So once makalculate nito nimo, moro to i-set nimo sa imong resistance. So again ha, within this range gyud ha, safest ta ayaw paobsi. Again, kung gusto mo mabuhatan sa tinuod, pinaka safe is ayaw paobsi ay imong resistance. Okay, sakto. Iyon ka kanang pareha sa mga solar lights. Yes, nakatry na ka nga project sa una. Para sa mga solar lights, mo-off na sila. You can try DC motor, mga DC motor para protected siya nga di siya mabuto. Mo ni magamiton nimo, di ba? Mag-series rabya ka nag-resistor gyud, mo gyud basic. Okay, katoy drawing ha. Let's say nakay device. Drawing ta. Let's say you have a power source here. Nakay device nga paandarod, wa ta kay baw. Okay, natay device nga paandarod, wa ta kay baw kung saan na siya maybe katong fan ba kaha? Gusto ka limitan nimo ang kuryente tungod kay imong source kay dako ra kay ampere naman ay rating sa imong battery naman ay miingon nga rated 5 amps then 12 volts, meaning more na iya maximum ha, di na ingon ha nga pag saksak nimo 5 amps then no, ang 5 amps class mag-agad na sa imong device mo na siya atong karon class kay base ato ang dipang calculate diri mag-agad na ang current, ang steady diri isang voltage. So kung imong device gamay rag kaon sa ampere, of course ang iyang ma-register sa imong pagsukod gamay ra pod nga ampere. Di ingon nga 5 amps dayon. Mag-agad na sa imong device, especially sa iyang resistance. So kung nakay device sensitive kaayo para di kay siya mapiktuhan, mag-series ka og resistor. Mo ganing tawag ani niya nga technique current limiting resistor. Magkabit ka para iya mapigilan ang kusog kay nga surge sa current. Okay? So mo na siya. Solar lights, fan, LED, basic meaning LED, mo ni kanang kuan basic. So again, connect mo bisag single ra nga LED ha. So again, if you have 5 volts, I think 5 volts murag makita din mo 5 volts or kanang inyohang ang good example sa 5 volts is imong cellphone nga charger. If wala ko na sa'yo pa 5 volts na dyan ang cellphone ari talo nga ban so class pwede mo ka ng cellphone charger man no. 5 volts or maybe ang uban 12 volts. So if namo ana nga source, then gusto mong pasigag, let's say this is a blue LED. Mura gito yung tigaman class kaning sa akong problem. Kaning forward voltage 3.6 o butang day ka kana 3.6 volts dayon na. Kunya gusto ka nga musiga na ay gid kalimtig butang og resistor kay di gani butangan na mapawong din na masunog din ang LED. So para safe butang din kag resistor. Kunya problema magina question gina for every problem magina ang challenging kung real life application unsa may resistor nga ako butang. Aw gamit din ka sa katong series nga kuan series nga kanang mga formulas. So mo ato imo i-subtract ning 5 volts minus 3.6 divide by the current here. And class, if you're not sure with the current of the source, then ngadto pug ka sa datasheet. Meaning kung unsa ray maximum current sa LED. Okay, kaya ang LED class naman ay maximum current na pud nga kaya. Ma-exceed siya na buto pud siya. So mo ni tanawon the forward voltage and the maximum current nga kaya sa LED. Unsay purpose forward voltage? Dili makitaan kung o unsa nga amount of voltage ang kailangan para musiga siya. If lesser anang ang voltage, di musiga. If more pod, depende sa current, buto pod siya. Okay, so walay pangutana. Do you have any question so far? Okay, nan. So, more inyo hinuduman, then, I think, dili lang sa takutob. So, just, kanang kuan na lang, watch na lang sa continuation ani kay ako i-cover up ang Kirchhoff's law, then Maxwell. Actually, wala ni sa inyong module but this is very important, especially kung nana mo sa higher subject. Kaya don't worry class kani, inyo maning actual gid kani siya. Pero, pwede nung mag-start karon and I guarantee you kani mo work gini siya. Kani itayo ninyo search mo mga datasheet sa LED mo work gini siya. So ang remaining nga mga lessons ni ani ako na i-record din ako ilang i-kuan i-upload. Okay, anyways kanang kuan lang ba to kanang dali lang naman.